Hi there. This video is just to talk about exercises from 4.1. Hopefully this will help you certify if you've gone through these exercises that I've put up here. Okay, have fun. What's the first exercise that I picked out? Well, let's see. Right, it says here, find the domain and the range of the given relation. So we know that it's a relation, and you'll find out why later, because that's one of the things we have to determine. Remember, we're going to use the vertical line test. But right now, it's asking for the domain and the range. What did we say to figure out the domain? You look from left to right, and since this is already a box in itself, you're just checking out what is the width. In other words, what are the boundaries on the side of the walls of this box? That will determine the width. Now, if you see here, the notches are, are scaled by 1. So 1, 2, 3, 4. And then this goes from 0, -1, -2, -3, -4. So you see that these are the markings of the y values, and these are the marks for the x values. So if it'll help, you just, we can mark these as, and the x-axis this way. This is the origin, 0, and then that's 1, 2, 3, and 4. So you see, there you go. And then you go to the left, -1, -2. And then at the below the y-axis, that's -1, -2, -3, and -4. So hopefully that'll help you to determine the domain. So what is the domain? It should be the closed interval. So you go from left to right. You look from left to right, and as you can see, the box in itself is contained from -2 to 2. Now to check the domain, to determine the domain, the range, now you go see if you can have a bottom of the box and a lid to the box. Here, the bottom starts from -4 and the lid ends at -1. So you see the range of the y values, so you go from bottom all the way to the top. The y values range from -4 all the way to -1. Remember that this is an interval, so the only way this will make sense is if the left number is always less than the right number. Left number must be less than the right number. Because this is the lower bound, that's the upper bound. Lower bound, upper bound. Now the next question that pertains to this problem is that determine if this relation is a function or not. And if it says if it is not, you're supposed to identify two ordered pairs as proof. Okay, so what do we use? We use the vertical line test. So, and here the vertical line test fails because it meets the box in 2 points. In fact, if you have the vertical line through this side, it coincides with the side of the box, even here. So to give us proof that this is not a function, okay, as proof that it is not a function, you have to give ordered pairs where you have the same x values. So in this case, we could use -1 for the x. See where that is. If you check what this ordered pairs for this point is, it's -1, -1, and another one is -1, -4. So you have -1, -1, -1, and 4. You see how you have the same x coordinate to prove that you have an ordered pair that has the same x coordinate. Otherwise, if you just take these two ordered pairs with the same y values, it doesn't prove anything. It just says that they have the same y value, but they have distinct x's. You see? Now let's do another one. So another set of ordered pairs we can use. Another set of ordered pairs. Okay? Anywhere where you have the same x. So suppose we try this ordered pair starting from when x is negative 2, I mean positive 2. So 2, say if you want negative 2 works, negative 2 for the y values work, and as well as negative 3. So 2, negative 2, 2, negative 3. So again, we've shown that you have the same order x values, which makes it not a function, only a relation. Alright? So let's continue with the next problem that I've picked out from your Precertify. Right, determine the domain and range of the relation y is equal to 4. And then the next question is this a function? Well, first of all, do you remember what you have when you have y is equal to 4 in chapter, I believe it's chapter 3. This is a line which is horizontal. So if it's a horizontal line, it goes through the y-intercept. It has a y-intercept. Remember, the y-intercept is at 0, 4, because you just have a horizontal line. Okay. Now, what are the ordered pairs that comprise this line? Well, one is 0, 4. You could have another one here, say 1, 4, 2, 4, 3, 4, etc. So all of these would have ordered pairs where 4 is always the y-coordinate, which tells us that what is the domain and range. Like I said, when you've determined the domain and range is to find out, can I put for the domain, can I put a box? Can I put walls on the box? Unfortunately, we cannot, because this will extend all the way there, all the way there, which means our domain would be from negative infinity to infinity, because you cannot really contain this line in a walled box. Now, what about the range? Well, we only have one element for the range. It's the number 4. Okay? It just so happened. So here's a situation where you have the domain, where you have all the set of real numbers. Okay? Set of real numbers. And every real number is paired to the number 4. So that's why the range is just the one element made of one element, which is equal to 4. Question, is this a function? Well, all we have to do is just draw a vertical line, and it only crosses the horizontal line once. So yes, it is a function. Okay, that might be, I don't know if this was asked, but I know that this problem about finding the domain and range was asked here. Okay? Well, as a spin-off to this, suppose we're asked to find or determine the domain and the range, okay, of the function or relation. So let's say we take the relation x is equal to negative 3, maybe something like that. Now remember, if you have x is equal to negative 3, it determines a vertical line. So you go negative 3. Oops. Okay. So is this, how do you find the domain and range? Well, in this particular case, the ordered pairs that are generated here are just negative 3 for any y. Say this is 1, 2, etc. Negative 1, negative 2. Okay. So this ordered pair would be what? Negative 3, 2. This ordered pair would be negative 3, 1, and so on and so forth. So that means for this kind of relation, all the ordered pairs would have x3 and some y value. It doesn't matter what the y value. So in that case, if this is the set of ordered pairs that is generated by this relation, the vertical line, the domain would just be the element, one element, it's negative 3, and the range, as you can see, it's just it's a vertical line. So you cannot put a bottom to the box and a lid to the box. So the range would be all real numbers. All right? So question, is this a function? Well, when we draw the vertical line right through it, it coincides itself with this vertical line. So no, it's not a function. Okay? So if you have a horizontal line, the domain is just the y value I mean, the range is just the y value. The domain is all real numbers. Whereas if you have a vertical line, it is not a function, it's a relation where the domain is, oops, let me write that as negative. So the domain is just composed of just the x element that's given here, which is -3 in this case. Okay, and the y values could be anything. That's why the range is all real numbers. Let's continue. Now, what is this? This is from your PDF files, but I just changed your f of x. So let's just practice on evaluating the function for whatever the argument is. Remember, this is what we call the argument. So f of this means whenever you see this x, that's where it is. So you say, what is f of, say, 1? That's just evaluating at x equal to 1. So -3 times 1 plus 5, you get 2. Right? Now what about if you say, what is f of x squared? Then again, it's the same thing. You replace the x by what? Whatever is in the argument. So -3 times x squared plus 5, that's just -3 x squared plus 5, and that's your answer. Now what about f of x minus 1? So this just say that if I have the x here, instead of the x, I replace it by this term. So you go x minus 1 plus 5. And we do a little bit of work here because you have to just simplify. You're going to have -3x and a -3 and a -1 would be +3 plus 5. You're going to have -3x plus 8. Okay, now here you get two expressions that they're being asked for. It says f of x plus a minus f of x. So what you're going to do is just evaluate what this is. So that's equal to -3. Replace this by x plus a plus 5. Okay, this whole thing is just this part. Okay, minus, now you replace the function f of x in here and just substitute. So you plug it in here, it becomes minus -3x plus 5. And the rest is just simplifying. So if we simplify, so the red expression is what constitutes or what is f of x plus a. And then the green one is just copying the function. You see, it says this f of x plus a minus the original function. And let's go ahead and simplify. So you expand this one, you distribute that as well, so you're going to get -3x minus 3a plus 5. Now you have a negative times a negative, it's a +3x and a -5. And then from here you inspect and just say, well, is there anything that can be canceled? These are negative and positive. That's negative and positive. So the only expression that's left is just -3a. All right, now look at letter D. Remember, in letter D it's very similar, but instead of the H here, instead of the A, you've got an H. So that means this whole thing, okay, would just be from based on letter C, it'll be -3h. I mean, what you can do is just try and expand and replace that by the h. You'll get the same thing, divided by the h, and what you have is -3. Now there's something special about this. Because this is a linear function, letter D is what we call a slope of the line, secant line of the function. But in a linear function, the secant line is the line itself. So you see the slope, to evaluate this, you always get the slope of this line. This is only true when you have a linear function, a linear equation right here, where it's in the, you have a slope, and even if you don't have a y-intercept other than 0, if it's not 0 or whether it's 0, then it's still, you get the same, you still have that slope. Okay, now let's go to what some of the Precertify that I looked at. Let's see here, determine f of x plus a minus f of x. Now you have a different kind of function. So the function here is the square root of x minus 5 minus 4. We can also determine the domain and range of this function just for the sake of, more exercises to help you in case this appears in your homework to certify what's the domain. Now remember, the domain is anything that's inside the radical must be greater than or equal to 0. So you're saying x minus 5 has to be greater than or equal to 0. So add 5 to both sides, you have x is greater than or equal to 5. And for that case, if you write it in interval form, we say the domain is from where? You start from 5 all the way going to the, remember this pointy thing of the greater than symbol is also like an arrow. So it goes all the way to plus infinity. Right? So that's the implied domain. Now how do we evaluate this? Well, from here, okay, replace the x by what? X plus a. So it becomes now, this is now equal to the square root of, all right, so what is in place of x? It's, you replace it by x plus a. So x plus a minus 5, all right, minus 4. So this whole thing is, what is f of x plus a? Now it says you take off the original function. So minus f of x, just copy the whole thing. So we have to put it in parentheses. So it's going to be the square root of x minus 5 minus 4. And then when we simplify that, you're going to get the square root of x plus a minus 5 minus 4 minus the square root of x minus 5. And then when you distribute that negativity, that becomes plus 4. So you see what gets canceled is just this term. And there's nothing else you can do to simplify these two expressions right here. So you leave it the way it is. Right? And that's your final answer right here. Okay? Let's see what's another problem that we have. Now here, determine the g of x plus a minus g of x, given that this is your function. Now here we're going to work a little bit harder because there's more expressions of the x involved. So what is g of x plus a? Copy everything, put everything here in place of x squared. You're going to replace, you're just going to replace this by x plus a, again there, x plus a. So let's go ahead and work this out. So this is now equal to minus 2, what is x now? X that's been squared, it's going to be x plus a squared minus 2 times something, okay, plus 1. So what is this? This is just g of x plus a, right? This whole thing is g of x plus a minus, then you take the original function and just copy it here. Okay, so let's take the original function and copy. So don't forget your parentheses. So minus 2x squared minus 2x plus 1. Okay, so the rest of this is just simplifying. So now let's go ahead and rewrite this. It will be minus 2 times, now what is x plus a squared? Remember, it's not just x squared plus a squared, because there's a middle term, because this is foiling it. So it'll be plus 2ax plus a squared, all right? And then minus, let me go ahead and distribute the negative 2. So minus 2x minus 2a, all right? And then plus 1. Then what happens here? When you distribute the negativity, basically what you're going to do is just take opposite signs of each of the terms. So it becomes plus 2x squared, okay? And then plus 2x minus 1. Now let's see. Keep going. You're going to get minus 2x squared. Then you have a minus 4ax. And then minus 2a squared minus 2x minus 2a plus 1 plus 2x squared plus 2x and then minus 1. Okay, let's see. Is there anything that we can cancel out? Yes, we cancel this out. They're opposite signs. What else? These are opposite signs. These are opposite signs. Can you show me what else that can be canceled? I think that's it. So now we're left with minus 4ax and then minus 2a squared and then minus 2a. And that's your final answer for g of x plus a, g of x plus a minus g of x. And please make sure that we got everything covered. I think so. All right, so that's it. Okay, so this is, again, here we have the situation where we have a linear function. So what do you think would be f of x plus h minus f of x all over h? We should get minus 7. So let's see that if that's what we are going to get. So this is equal to minus 7 times, replace the x by x plus h, okay, minus 2. So what is this so far we've done? This is just your f of x plus h, this part, minus the original function, so it's minus 7x minus 2. Divide the whole thing by h, and the rest is just simplifying it. So you get minus 7x, right? And then minus 7h minus 2, and then that becomes plus 7x plus 2. And you see how we can simplify and cancel out the opposite signs on top. So there's that one and this one, and then we're left with a minus 7h divided by h. You get minus 7. And see what I told you, that if it's just a linear function, this difference quotient will always give you the slope of the line. Oh, here's another function. You have g of x is equal to minus x squared minus 2x plus 1, and you're asked to determine what is g of x squared. So again, that just means that all you have to do is whatever is in the argument of g, you replace it. So this is minus 2 times something squared minus 2 times something plus 1. So what do you replace in place of the x? You replace it by x squared. Squared. So when you rewrite everything, that becomes minus 2x to the what? 4th minus 2x squared plus 1. And that's what your g of x squared is going to look like. All right, next problem. Consider the relation f 5x minus 2y plus 3x minus 6y. It says rewrite as a function of x. What does this mean? All I have to do is really solve for y, because y is a function of x, because remember, y is equal to f of x. So let's go ahead and solve for y. So if I want to solve for y, I think I'm going to add 6y to both sides, right? Because 6y is bigger, and then put the 5x on the other side. So minus 5x here, minus 5x. So what will you have? So far you're going to get, let's see, you're going to get a minus 2 and a 6 would give us 4y. And then you're going to get, this is 3 minus 5 is minus 2x. Then the final thing you're going to do is divide by 4. So now you get y equals minus 1/2 x, right? Because look, this simplifies. Now what is y? Y is your f of x. So for your final answer, you say f of x is equal to negative 1/2 x. Now it says evaluate when x is 3. So that means when x is 3, all right, all you just say is f of 3 would be negative 1/2, negative 1/2 times 3 is negative 3/2. And that's it.